Hey guys, long time no see. Kinda crazy seeing you here of all places. Although the first law of thermodynamics for open systems is a damn cool topic. So then again, maybe it isn't so crazy seeing you here after all. Okay then, let's get this party started. First law of thermodynamics not ringing any bells? Then it would probably be a good idea to go ahead and check out our first video about the first law. We'll start by looking at how it works for closed systems. But if you've already got that down, we can jump right into the major differences between open and closed systems. So first, let's put the first law of thermodynamics for closed systems out on the table. That'd be this guy right here. Super straightforward. If you remember, we're leaving out all that stuff like kinetic and potential energy, along with loss. The most important difference is that with open systems, we have to deal with the flow of mass. This mass flow influences our system's internal energy, since in addition to the internal energy of the mass itself, we have something else to account for. To see what I mean, let's take a look at a system with some material. Mass flowing through it adiabatically. Quick reminder here, adiabatic just means that there's no transfer of heat outside the boundaries of the system. So it's like perfectly isolated. First, we block off a certain section of the flowing mass, which at this moment in time has an internal energy U1. We don't know the exact value, of course, but with internal energy, it doesn't really matter anyway. Now at a later moment, the mass in question might end up over here, for example. On the way, our system passes through a turbine, which takes the opportunity to snatch a little bit of energy. We'll go ahead and call this energy technical work. Now, in this second instance, our system has an internal energy U2, which is also unknown to us. What we're interested in knowing, however, is the difference between U1 and U2. Using our formula, this is what this would look like. The Q we can just cross out, since the system is adiabatic after all, and heat Q has to be 0 anyway. And work in this case is just the technical work from the turbine. Yeah, no. In addition to the technical work, we also have to account for the volume displaced by our mass. This is easily expressed as the product of volume and pressure, like here. Now we can solve the equation for the technical work, writing delta U over here. We bring the stuff in the parentheses over to the other side and give it a minus sign. So we write out delta U and multiply the stuff in parentheses by -1. Now if we sort the whole thing by the indices, we get this beautiful thing here. And now the hardest part's over. Looks like someone decided to introduce a new state function here, namely what's called enthalpy. This is because internal energy U, pressure P, and volume V are all state functions themselves. So you can clean things up a bit by combining all these values under enthalpy H. This simplifies the whole story, giving us the simple expression W equals H2 minus H1. Is this a fine-looking formula or what? If we weren't dealing with an adiabatic system, we'd have to throw in heat. And if we cared about kinetic and potential energy, it's not too hard to expand the formula to this one here. And with that, it looks like we're done again. So let's go over all this once more real quick. Open systems involve a flow of mass. This is why the volume displaced by the mass is an additional factor in the first law of thermodynamics for these systems. This displacement is expressed as just the product of pressure and volume. And finally, we took this displacement and put it together with internal energy to get the celebrated property we call enthalpy. And in that way, we are able to arrive at a truly compact way to write the first law of thermodynamics for open systems. Don't forget that we left out kinetic and potential energy here, along with loss. If you put in all that stuff, the equation would look like this. We'll look at this form of the equation another time. As a rule of thumb, you can basically say that enthalpy H is always relevant in an open system. And with closed systems, the important thing is internal energy U. Awesome, people! That's one more topic down. Of course, there's more to go, starting with the next video. So just stick to it, and we'll see each other soon.